Okay, so for our first example, we have a cubic monomial, so negative 4a to the third, times a quintic monomial, 3a to the fifth. If we had to multiply those together, what would I get when I multiply the coefficients together? Negative 12, right? Because negative 4 times 3 is negative 12. A to the third times a to the fifth would be a to the eighth. So the product would be negative 12 a to the eighth. So far so good? Not too crazy? All right. Here we still have a monomial times a monomial. It's just now we have a degree of 6 in the front, and we have a degree of 5, so a quintic inside the parentheses. So 2m squared z to the fourth times 8m to the third z squared. So let's just multiply our coefficients together first. 2 times 8 makes 16. Come on. Slowly getting there. And then my m squared and m to the third would make m to the fifth. And it would be z to the sixth. Good. Yeah? Monomial times a monomial? Feeling okay? Nothing too crazy? Okay. What about a monomial times a binomial? So negative 2x. So we have a linear monomial times a cubic binomial. So here we're going to use that distributive property. So we're going to take the negative 2x and we're going to multiply it by 8x to the third. So negative 2 times 8 becomes negative 16, x times x to the third, x to the fourth. Negative 2 times a negative 9 would be positive 18, good. And then x to the third. Done. Liking life so far? Okay, good. How about a binomial times a binomial? So we have a linear binomial, 3x minus 4, times a quadratic binomial, 2x squared plus x. Okay, you've probably heard the word FOIL before. I actually use the word double distribute because in my head that's what we're doing. So when I teach it, I didn't have any of you guys in Algebra 2 last year. So we take that 3x and we multiply it by the 2x squared, which is going to be 6x to the third. And I'm going to distribute that 3x, which really is your outer, first outer, which would be 3x squared. So now I distributed the 3x. Now I'm going to distribute the negative 4, which is really your inner. So negative 4 times 2x squared would be negative 8x squared. Negative 4 times x, thank you, would be what? Negative 4x. And now all we have to do is just combine our like terms. Do I have any other cubic terms? Nope, so that comes down into our answer. 3x squared minus 8x squared would be negative 5x squared. Bring down a minus 4x. I mean, you could factor out stuff, but then you would just get back to what we started with. So when you're multiplying, just leave it as it is. Okay? All right. Here we have 3 different polynomials. We have a quadratic monomial of 2x squared, linear binomial times a linear binomial. So x plus 1 times x minus 3. What would you guys do first? You got some options.
Factor for the first one, and then do the answer and do the second one.
So you would distribute the 2x squared first? Sure, we could do that. I would get rid of this and do this part first because it would be smaller numbers to work with. So if we FOIL that or double distribute, x squared plus u minus 3x plus 1x minus 3, which would go to x squared minus 2x minus 3. And now bring down that 2x squared. So then all I have to do is just distribute that 2x squared to all three of those terms. So we get a 2x to the 4th minus 4x to the 3rd minus 6x squared. It would not have been incorrect to do the x squared first, and I'll do that over here. Let me do that in a different color. Not pink, you won't be able to see that. So if I distribute the 2x squared first, then you would get 2x to the 3rd plus 2x squared. And then we would have to multiply that by x minus 3, which would get you 2x to the 4th minus 6x to the 3rd plus 2x to the 3rd minus 6x squared. So we get 2x to the 4th minus 4x to the 3rd minus 6x squared. So we get there either way. It's just, do you want to deal with larger numbers in the beginning or larger numbers at the end? Okay, how about this crazy looking one? Cubic trinomial times a linear binomial. 3m to the 3rd minus 2m squared plus 4 times 3m minus 5. So if you think of the double distribution that I speak of, that's what we're going to do. I'm going to take this 3m to the 3rd and I'm going to distribute it to that 3m. So 3m to the 3rd times 3m would be 9m to the 4th. Now distribute it to the negative 5 and we get negative 15m to the 3rd. All right, so I took care of the first term in that trinomial. Now let's take the negative 2m squared and distribute it. So negative 2m squared times 3m would be negative 6m to the 3rd. Negative 2m squared and a negative 5 would be 10m squared. Now we got to take the last term in that trinomial, which is the 4. 4 times 3m would be 12m. And 4 times negative 5 would be negative 20. Combine like terms. Do we have any other 4th powers? Nope, so that comes down. Powers of 3. Looks like it's going to be what? Negative 21. So negative 21 m to the 3rd. Any other squareds? No, just one squared, right? So 10m squared comes down. 12m comes down. Minus 20. How would you classify that? Yeah, so it's a quartic. Yeah, polynomial of 5 terms. We don't have a special name for anything beyond 3, right? So we just say polynomial of 5 terms. Degree of 4 or quartic. Okay. So we're feeling pretty good. So now let's do special products. What happens in this scenario? When we have the same terms, we have a p and a 7, but the signs are different in between. Yeah, right? The middle terms are going to cancel out. Do you guys see how that happens? So if we go ahead and FOIL or double distribute, p times p is p squared. I don't know why I just wrote an r. P squared minus 7p plus 7p minus 49. Which, if you remember, that has a special name. It's called a difference of 2 squares. Yep, difference of squares. So they're both perfect squares. Okay, so that's something that's like a shortcut. If you see that right away, you can kind of just ignore the middle terms and take it right away to the p squared minus 49, which is kind of nice to be able to recognize that. So what would this go if we just went with a shortcut?
There's
36m squared, yep, minus 25, right? So we can see that since the numbers are the same, just the signs are different, the middle two would cancel out. Would it be incorrect to do all the work? No, it's not incorrect to do all the work. It's just sometimes it makes it nice to just get quickly to the answer. All right, what happens if you have an exponent of 2 outside of your binomial? Right, so you have to multiply everything by 2. Or not multiply everything by 2, you have to rewrite it twice. Right? So that becomes m plus 7 times m plus 7. Anybody get to the answer right away without working it out? It'd be m squared plus what?
14.
Yeah. M squared plus 14m plus 49. Can I show you a little shortcut that I use when I see these problems? So, common mistake, I don't know why students do this, but they do. Common mistake, don't do this because this is not right, is they'll just take that m squared and then make it plus 49. That is not the correct answer. You can't just square the m and square the 7. That only works when this operation is multiplication. And that's not multiplication, it's addition. But to get that middle term, what you can do is just multiply all these things together. So 2 times 7 is 14 times m gets you to the 14m. It's kind of cool how that works. So you square the m squared, square the 7 to get your first and your last, to get your inner, multiply everything. So if this would have been let's erase this. This would have been an m plus 10 squared. What would be your first term? What would be your last term? What would be the middle term? 20m. See how that works? What if it was 2x squared plus, not 2x squared, 2x plus 5 squared? What would be your first term? What would be your last term? What would be your middle term? 20x, right? If you multiply everything together. 2 times 5 is 10 times 2x would be 20x. What if it was a subtraction problem? What if it was 3x minus 1 squared? What would be your first term?
9x squared.
What would be your last term?
1.
Positive or negative 1?
Positive.
Yep, so whenever you square something, it would become positive. What's your middle term going to be? Negative 6x, right? 2 times negative 1 is negative 2 times 3 is negative 6. You see how that works? I don't know, kind of cool, maybe. So, let's get really complicated.
Oh boy. I just went from right here to all the way over here.
Yeah, it did.
So let's analyze what's happening here. So in our first set, we kind of have a binomial and a monomial being added together. So we have 3p minus 2 plus 5q. That's being multiplied by 3p minus 2 minus 5q. Is this anything different than our difference of squares that we had previously? No, because my first term in this case is 3p minus 2. My first term in here is 3p minus q. My last term is a 5q. Here I have a 5q. So the only thing that's going to happen is the signs are going to change there. So what's going to happen to the middle terms? They're going to end up going away, right? So technically, I'm only going to be left with the first term times the first term and the last term times the last term. Now, if you can't see that right away, what would be your first instinct to do? Just multiply everything, right? So let's go ahead and just multiply everything right away first, because maybe we didn't notice the shortcut. So if I take that 3p and multiply it by that 3p over there, I get what? 9p squared. If I take that 3p, oops, overshot it, and multiply it by that negative 2, we get... I got too happy with my rainbow. Negative 6p. And then 3p minus 5q would be negative 15pq. Now let's take that negative 2 to everything. So negative 2 to the 3p would be negative 6p. Negative 2 to negative 2 would be plus 4. Negative 2 to negative 5q would be plus 10q. Now I just have to take the 5q to everything. So 5q and a 3p, 15pq. You can go underneath. 5q and negative 2, negative 10q. And then 5q, negative 5q, be negative 25q squared. I ran out of room too. So what cancels? The 10q's go away. The 15pq's go away. All right, so now let's combine all the like terms. Do I have any other p squareds? No. So that comes down. What happens to my p's? So negative 12p. And then we've got plus 4 in there. And then we've got a minus 25q squared. Okay. So if I had to rewrite this so that it was in standard form, so my highest degrees would be first, lowest degrees would be last, how would you rewrite it?
Just move the negative 25q squared in between the
Which would go first, the p or the q?
p.
The p. You always go alphabetical order. So it would be 9p squared minus 25q squared minus 12p plus 4. Okay. Now if we would have noticed right in the beginning, oh, those are the same terms first and last, just a difference of signs. So that means my middle terms are going to cancel out. All I really need to do, I don't know why, can I just erase that? There we go. Is just multiply the first term, which is here, by the first term here. Well, what do we get? Can we mentally do this in our heads? What would this go to? 9p squared. What would be your middle term? So this would get you negative 6. This would get you negative 6. So negative 12p. And then a plus a 4, right? And then what do we get when I do the last terms and multiply them together? Yeah, isn't that what we had previously? Just had to rewrite it. A little less work. So if you notice, well, my first term and my first term are the same. Last terms are the same, just opposite in signs. Just multiply the first and last. But that only works when everything is the same except for the signs. All right, let's do a squaring one of those crazy ones. This is it, last one.
I think we should do dot. You always make them better. Because I lose.
I think tomorrow should be strictly dedicated to.
Yes, agreed.
Tomorrow's strictly dedicated to dot game. I think we could handle that.
You can't explain, you just gotta fix it.
All right. We want to try it using shortcut method. All right, well, let's do we'll fully do it out first. So let's rewrite this twice. 2z plus r plus 1. So now he's going to multiply everything. All right. 4z squared. Good job, Emily. 2z and an r would make 2rz. Put them in alphabetical order. 2z and 1. 2z. Now I'll take the r to everything. R to 2z would be 2rz. R to r, r squared. R to 1 is r. Now I just have to take that 1 to everything, which really is not going to change anything, so it would just be plus 2z plus r plus 1. Combine like terms, any other z squareds? Nope, that comes down.
Shouldn't R be in front though?
Will you do, oh yeah, thanks.
Good catch, Jen.
Good job. R squared plus 4z squared. Then what would be next? RZs, because those have a degree of 2. How many RZs do we have? 4 total, right? 4 RZ. How many R's? 2 R's. How many Z's? 4 Z's? Yeah. And then how many constants? 1. Good. Okay. So now this would be a little bit harder to do squaring wise, the shortcuts. Can I erase this? Are we okay? If we wanted to do the shortcut, I would have to square this whole thing, which means I have to use the shortcut twice in the shortcut method. So if I use the shortcut using this method, I would get 4z squared. What would be the middle term? 4rz, right? Plus r squared. So that's what I get when I do that. When I square the 1, I get 1. I'm going to have a plus 1 out here. And then to get our middle term, we have to multiply everything again. Which that wouldn't get us to the right answer, would it?
No, because it's not a positive and a negative, right?
No. Yeah, I just wouldn't even use the shortcut method there because I don't think that's working out. Because we should have had, what, 2 R's or 4 R's?
2 R's and 4 Z's.
Yeah, that doesn't work out. All right, let's practice some of these. Grab yourself a practice space.
Which Josh?
That was good.